Welcome to BeeGraphy. In this 9th tutorial, we are going to continue from where we left off, which is creating this dynamic facade. A quick recap, we have already created the panels that rotate. We have created a framework that encompasses all these panels, and the thickness of all these pipes is being controlled, as well as the size of these diamonds. What we're going to do next is create a framework so that it connects to the building, and then we are going to introduce sunpath and attractor point logic here as well. So firstly, let us create pipes from this point, all these points that are the corners of our diamonds, to our main building. So let's begin. Where we can find these corners, we can find them in the diamond panel node. To check it once, I'm just gonna click it here. So these corners are not the points, the centers are these points. So where is this white points coming from? We can observe that it is coming from explode component that is exploding all these diamonds, and it is giving us curves, but it is also giving us points. In the previous script we did not use the points, but we can see them. Alright, so as we are exploding the diamonds, we can see that these points are coming out. Again, if you remember, the curves were coinciding and we had to cull curves so that the duplicate curves are removed. Same thing in points. This point over here is actually a system of 3 points. One from this diamond, one from this diamond, and one from the lower diamond. And this point over here has got 4 points from 4 diamonds coinciding with each other. So unlike the lines, the points are even worse in coinciding with each other. So I'm going to put a panel and just check what do we have here. Right, so we've got 23 diamonds with 4 points each, and if I flatten it, I'll be able to see all the number of points. So we've got 92 points, and just like before, I am going to simply cull them. And in this case, we are not going to use cull curves. In this case, we are going to use cull duplicates. As soon as I do this, we can see there are only 38 unique points that needed to be there. But in case of lines, it was 60 lines that were unique. All right, so we've got our points, we've removed the duplicates, and now we're going to use them. What I'm going to do is I'm going to create a line that starts from here and goes towards the surface of the building and stops there. And then around the line, I'm going to create the pipes. You can see there are several lines components. There is line SDL, line by 4 points. So line SDL is what we are going to use. Line SDL means line start, direction, and length. Start, direction, and length. Start means from what point is it starting. Direction means you have to give it a vector, which direction is it facing, and then the length, how far do you want the line to go. So this is perfect for our case, because the original line that we've already used, it requires 2 points. We have 1 point, but the other one we do not have it. Actually, let me try something. There is project curve. I was thinking if we could project these points on the surface of the building, then we could also use that, but it's fine. Let's use line SDL. We are going to put in points, and you can see that all these lines have some default direction and default length, and it is working just fine. Let me change the length and show you how it works. Right, so this is the length that it is that is being changed, and then there is the vector. By default, the vector is 10 10 10, which is 45 degrees from all axes, I think. We need to change that to -x. I'm looking here and I can see that my axis is x. I'm going to use vector x and I'm going to put in negative number. So this is just, I mean, the number here does not amount to anything because the length is being specified here. Right, so as soon as I put 2, it is perfectly stopping at the building. Yeah, 1 is halfway and then 2 would be the distance between them. Of course, you can connect the same number from when we were offsetting the surface itself. This offset, we've got this distance too. So let's connect it here. Make your geometries as parametric as possible, which means when I change the offset of my surface, I shouldn't have to change the line SDL, the length of my lines, separately. If I change it, this should be automatic, right? So that's what's happening here. The offset and these lines are now merged. And put in even 1 and it'll still be like that. And simply now we are going to pipe it up. Pipe. So before I do that, the radius should be the same as the radius of this pipe, which is also equal to the offset of my diamond panels. So this range input is serving all 3 purposes. Awesome. So now the framework is uniform and completed. One more thing that I would like to do is the offset, if it is too much, the surface offset, if it's too much, we are unnecessarily applying more material in these pipes. But if it is too little, then these diamond panels are going to coincide and touch the building. So we can even parameterize this by checking what's the distance between the center to the corner of my diamond, and then using that distance as the offset. So that's an exercise that you can do it on your own, but let's move on now. Let us connect let's connect this with the attractor logic. So we can have an attractor point somewhere, and this will be purely for aesthetic purpose, but there will be an attractor point and all these panels are going to rotate according to their distance from the attractor point. So let me introduce a point. Okay, let's just introduce a point and then we'll move it manually. So there is a point over here. Let us pull it up. So towards the x-axis, let me put in number 5 because the width of the building is 5 units. And then if I put in 6, then it will be on the surface of our offsetted surface. And then we can put in y and z. So 12 is a big number, so let me put in 7. Awesome. So our point is here. Let me put in a sphere so that we can see where the point is going. and let's take the radius and reduce it to 1. Then we'll remove it. Right, so our attractor point is over here. We need distances between the attractor point with all our centroids. We actually don't even need the centroids. The centers is also doing the same thing. However, since we already have a centroid, I think we should use that to reduce confusion. I'm taking this from here, and then I am putting in all the points from here. So in distances, I'll be able to see 23 different distances, and all of them range from 0 to 8. Perfect. I need to enhance it because the angle of rotation is from -90 to 90. So here is where I am going to introduce remap numbers. The source, so what remap numbers does is, how do I explain this? So let's say we are talking in percentages, 56%, 100%. Okay, so we've got a set of numbers that are in percentages ranging from 0 to 100. But at the end, I want to convert all these percentages into decimal that range from 0 to 1. So, I mean, mathematically, we know we'll simply divide all of them by 100. But when it becomes complicated, like in this case, the distances that are coming out are ranging from 0 to 8, but the output we want from -90 to 90. It's slightly more difficult. You can do it on pen and paper, but remap numbers makes it super easy. So let me just check once again. We've got this, and I've got 0 to 8, and even like 8.03. So let's, to be on the safer side, let's take in 0 to 20, 0 to 20, and then the target minimum is -90 and maximum is 90. So if I am putting in 0, I'll get -90. If I put in 20 in this number, I will get 90. I'll show you. And if I put in 10, I will get 0. Right now number is 5, so I'm getting -45. So I'll show you how it works. Yeah, so if I put in 10, that's exactly at the middle of 0 and 20. I'm getting what is exactly at the middle of -90 and 90, which is 0. And if I reduce this, then we get all these weird numbers, which it is calculating on its own. If it is 0, then we get -90. That is the target minimum. Let's put in these distances here. Now we've got 23 different numbers ranging from negative, right, so all of them are negative because the source max is 20. Let's reduce the source max to 10 so that we get a mixture of positive and negative numbers. So yeah, now it's perfect. Cool. And this is what will go into the rotation. Where is the rotation? Diamond panels, they are being offsetted and then they are being rotated over here. So this entire thing, let us take it below and then put it here. Let's arrange a bit. And this number will go into angle. So yes, it is responding to the sphere, but it is it is in radians. We need to convert it to degrees to radians and then put it here. Perfect. So The ones that are very close to it have got some rotation, and then as they're moving apart, they are rotating a bit less from the basic part. I want to make it a bit more gradual. Actually, if I put a 0 here, I think it would be very interesting to see. Yeah. So the ones that are very close to the sphere, they are almost closed. And then as we are moving apart, away from it, they are rotating a bit more. So this one looks better. We reduce the sphere radius. And now we'll move the sphere. Awesome. So the attractor logic is working perfectly. Let's give it some material before we move on. So we are going to do apply material, and let's give it a slightly brown color and metallicity up, roughness 0, and it starts to look really amazing. Then I'm going to have material for my pipes. Let's put all the pipes in one thing, make it black, and let me hide everything else. Awesome. And finally, our main building, the box. So let's give it slightly glass look with opacity reduced to 0.7 and hide the main box. And you can reduce the roughness to make it look glass-like. Awesome. Later on, you can introduce slab lines, slab thicknesses, so that it looks more complete, maybe balconies and stuff. But yeah, for now, I think this works. Secondly, we are going to work with the sun. The attractor point works perfectly. You can see how gradually the panels are rotating, because the attractor point is somewhere here. Perfect. So to create the sun path, what we are going to do is we are going to take the center of the building, and then we are going to create an arc, and then we are going to lift it up. As simple as that. So we've got our box, and if I type in centroid, we've got the center of the box. We're going to use this center to create our sun. So let's pull it down. Type in arc. You can see a quarter circle pop up. The origin will be this center. Angle 1 is 0, and let's use pi directly and see what happens. So it is going here. So this is the angle 1 and this is the angle 2. So let's take angle 1 as negative pi by 2. I'm going to use the same pi, and I'm going to introduce division. You see what I did, right? I did slash 2 and automatically a has got 2. And the divisor is 2 because I just typed in 2, and the dividend is what it wants. So angle 1 should be negative pi by 2, and wait a second, and this should be pi by 2, right? There will be a negative opposite component. I put it here, I put the same thing as angle 1, and we get our semicircle. You can do degree to radians and then put in degree values as -90 to 90, and you'll get the same result. We've got the arc. We can increase the radius, let's say 20. And then we are going to lift it up. So we're going to rotate it. We are rotating this. The center will be the center, sorry, the centroid of our box. It is the center of the arc as well. But we are going to rotate it not like this, but in XY plane. So let's, yeah, this one. And right now it is rotating this way. We'll correct that as well. But let's use degrees this time. Degrees to radians. If I put it here, it's going to go down. So we need it to be negative. And then we put it over here. Awesome. So we can control this. That's called altitude or azimuth of the sun. In winters it goes flat, and then in summers it's almost up, right? So we've got the sun path. We can hide the old one. Now I'm going to explain point on curve. Point on curve. What point on curve does is, you've got a curve, even if it is a square or a rectangle, a triangle, circle, a polyline which is continuous. You put it here, and then you can put in a parameter ranging from 0 to 1 in decimals, and that fraction of the line it is going to traverse. So let's say it is starting from 0 here. Let me put in a sphere for better visuals on the point. All right, so 0 is here on the edge of this arc, and 1 would be on the other end. So 0.5 will be exactly at the center. So this would allow us to place the sun through the day, and also this will allow us to place the sun according to the date of the year. All right, so this is done. Now what I want is all these panels to face the sun simultaneously. So somehow I am going to yeah, so there are two ways to do that. One is more simple, the other one is a bit more complicated, where I'm going to project this curve on the ground, and then I'm going to create vector from the building to the sun, a line, a direction, and then I'm going to make all these panels face that direction. So that is one way to do it, but that requires a bit more nodes and systems to accomplish, projecting, then creating these vectors and comparing those vectors. A shortcut would be to use this point on curve system, which is nice, very clean numbers like 0 to 1, and it starts from one end, ends at the other end. We can do remap numbers, take this in, the source minimum, this is our source, and the source is from 0 to 1. So source minimum is 0. Let me change that to 0, and the maximum is 1. And the target minimum and maximum will be according to this. So it's either minus 90 to 90 or 90 to minus 90. Let me just quickly check. Actually, let's just put it in. We don't have to check. And if it is opposite, then we'll simply flip it. Let me just put in 90 to minus 90 and see what happens. Let me get the panel and see if it is working fine. If it is 0, it is 90, and if it is 1, it is minus 90. And let us put this in the rotate angle, degree to radian, this one. This number goes to degree to radian. Now I'm going to change the position of the sun. Oh yeah, so right now it is not working. You see, it is not facing the sun. It is working in the opposite way. Yeah, so it is, so the edge is facing the sun. We need to flip it. I'm going to do this and this. So it should be minus 90 to 90. So I really like this. I mean, it's such a simple process. You don't have to understand everything. You can just do trial and error and fix things. So now it is facing the sun all the time. This works perfectly. We can see that all the panels are facing the sun every time. And also, if you want to go back to our attractor point, then you can simply connect this part, and we can then control the attractor point and see how they move. Perfect. What you can do next is increase the size of the box, change width, length, height, connect it with the number of floors, height of floors, and divisions of panels. So as soon as you increase the multiple height of floors or number of floors, the panel should also multiply to change their heights. That's all basic maths that you'll have to figure out, but it's a good exercise that you can look up. And also, another assignment I would say is to check out pipe variable and graph mapper. Just put in numbers, read about it, connect it with parameters, radii, base curves, and try to create a varying pipe, maybe like sine wave pipe. In graph mapper, you can take sine as one of the graphs and then try to create a pipe that is increasing and decreasing as it goes, and then probably connect it to your sunpath to give it some visual appeal. I think that was really awesome. All the issues, all the troubleshooting is really nice to occur. I'm always happy about it. Just a quick recap: we've got a box, we deconstructed it, we extract one of the surfaces, we subdivide the surface into panels. We use that panel to do two things. One is to create the frame, the diamond frames, and one is the panel itself, which we rotate. So this explosion is for our frame, all this line SDL pipes for the frame, and the panels itself are working here. We offsetted it a little bit and we rotate them. Then the angle of rotation is governed by two or three things. One, you can manually enter any angle you like. Two is the path of the sun. It faces the sun always. And thirdly, the attractor point. The angle of each of these diamonds rotate depending on their distance to the attractor point. The further they are, the more they rotate, or whatever you like. You can change the maths to your need. So hope this was very helpful, and it demonstrated several new aspects, new nodes, new logics, and you found it very useful. So see you in the next tutorial.